I guess while we're waiting, I'll introduce myself. My name is Nissan. I work for Netflix, core contributor to the Metaflow team. I'm co-hosting these office hours with Savin. These office hours just resumed this year. This is the second session. So you haven't missed much this year, Nick?
All right, that's good.
All right, I think I'll start kicking it off. So a couple housekeeping announcements. This talk will be recorded and posted on YouTube afterwards. We do have a Slack channel, Ask Metaflow. If you're not there, please join and we can continue the discussion there afterwards. And of course, like and start a repo on GitHub. Yeah, today we have Nick from Lacework that'll be giving his talk. Nick is going to cover how he uses Metaflow to look for security vulnerabilities. So Nick, take it away.
Cool. Yeah. Hey, everyone, and thank you for having me. I'm going to have some slides prepared, so hopefully it won't be too boring. All right. Do we see a slide that says Riskwatch, high-fidelity, yada, yada, yada?
Yes.
Cool. Okay. Nice. All right. Yeah. So, so this basically today we're going to be talking about like how we're doing some like sort of static and dynamic code analysis, and we're using Metaflow as our workflow engine to like figure this all out. So yeah. So first of all, like I'm Nick, and working very closely with me on this project is Jeremy, and we also have a few other people who are on this call, like Zeki, Zhen Chao, as well as Yunjun and Terry, and maybe a couple others who joined that I didn't see. And we all work at Fortinet on the Lacework FortiCNAPP product. And yeah, and we're like Jeremy might be like stepping in to answer some questions that we split responsibilities on. So if you hear him speak up, then he's a co-contributor. Okay, yeah. So what I want to talk about today is what exactly we're working on. Why like Metaflow we thought was the right tool for the job. What exactly we're doing with it. The things we sort of experienced with it. Some extensions that we've been like working on to like make our work a little bit easier, and our thoughts on like how we have scaled this out. So yeah, so what exactly are we doing? Like I mentioned like code analysis, like static and dynamic, but I mean, honestly, like those are sort of technical terms, and like honestly, like even I like sometimes like have trouble distinguishing which is which. So yeah, let's figure it out. So first of all, like we're working on a cloud security platform called Lacework FortiCNAPP, and our customers like put our software in their cloud environments, like their EC2 instances and Kubernetes clusters and stuff like that. And we monitor them and we ingest data and we alert them if we detect like that activity. And through that, we have like this like a monitoring agent, like a small like daemon that will run in the background with privileged permissions, and it will basically like figure out what's going on in the system and send it back to Lacework for ingestion and analysis. And we are working on this agent. So our agents currently, we have like tons of features, and I won't like worry you with going into like everything that we're doing there, but we're working on a new feature that is basically figuring out when like a vulnerable code path in an open source package is executed. And that is sort of like the holy grail of like vulnerability detection, because basically, yeah, like for reasons I'll get into it later. But yeah, basically we have like we want to give the agent a list of vulnerable code paths to watch, and we need to figure out what that list is, and that is a really hard problem. So yeah, and so our customers like they have all these open source packages, and the security industry with vulnerabilities it's always been sort of a uphill battle, because there are like tons and tons and tons of packages with tons and tons and tons of vulnerabilities. And you can't treat like every vulnerability as super, super high priority because it's just not possible. And so there's some kind of prioritization that has to go into here. And so for this prioritization is why we're here. We're trying to figure out like what is real. And so we have this sort of chart of like, okay, like what is good, what like to ignore, and what is bad to ignore. And so like if there's real risk and we don't remediate it, then that's really, really bad. And if there's like false risk and we remediate it, then that's okay, but also like burn some time and energy. And then like if there's false risk and we don't remediate, that's also fine. So yeah, there's like this sort of like calculus that security engineers have to figure out when they're like triaging these vulnerabilities. Yeah, and so basically like without going into like the nitty-gritty details of what we're doing, we're taking lots and lots of artifacts and source repositories, and we're trying to just like stuff them all into one big data processing engine and figuring out like what's vulnerable. And so, yeah, basically like we are doing lots of analysis, and we thought Metaflow would be a good tool here. So yeah, let's dig in a little bit more there. Also, since we're moving on to another topic, if anyone has questions, like feel free to interrupt. Like, I would love to like have a chat about like the things while they're on the slide rather than going back. But
hey Nick, I've got one kind of meta question. Have you run this across the Metaflow code base at all?
No, we have not actually. Yeah, I think it would be really cool to do that though.
Yes, so do I.
Yeah, right now, like, yeah, I mean, like, we're still developing the product, so I would say that like I won't promise the moon just yet, but like I would say like one day that'll be really, really cool to do. And I'll share the results about that.
Yeah, thanks.
Yeah.
So just so if I understand the problem set up correctly, you're detecting when the vulnerabilities are executed real time?
Yeah, exactly. So yeah, the agent is running on our customers' machines, like in their cloud environments, and has privileged like permissions to like basically hook into like where like and like the mechanics vary a little bit, so I won't like super go into that, but like it can basically tell like when like which lines of code are being executed. And if it detects that, like it says like, okay, like line 30 in like this file, or like that we have like figured out like that's what's running right now, then we will record that and send it back to our platform to alert customers.
Awesome, got it.
Yeah. So yeah, I mean, like to give a little bit more insight, like the way the security industry has dealt with this in the past is like, for instance, like to figure out if there are like vulnerabilities on your machines, they would just like take like container images and they would scan them, and they would see, okay, like we see like OpenSSL has like hundreds of like super high vulnerabilities for this version. And so like we'd go tell our teams that are using the container image to go fix it, but they might not be using OpenSSL. And so they say like, okay, we're not using it. And so the next thing that we built was figuring out which packages are actually running. So like we can like use our agent to tell like, okay, OpenSSL is running on the machine. And so so the security team can take that and go back to the dev team and say, hey, like we saw that OpenSSL is active on this machine, and we see these high vulnerabilities, and we would like you to fix them, please. And then like the third step, which was what we're working on now, is we see like the security team can say, we see OpenSSL running on this machine, and we've gotten confirmation from Lacework that the actual vulnerable lines of code were executed. And so please like fix this ASAP because we've just had like an incident. So yeah, so high efficacy is the goal here. Cool, yeah, love the questions. So please keep them coming. But yeah, let's talk about like why we chose Metaflow for this, because I think like maybe like one thing y'all are thinking is like this is not like machine learning or like super closely correlated with AI. It's more like big data processing, and so I think like this might be useful to like figure out like what our thought process was and why we got value from it. So so specific requirements that we have. We want like a lot of like customization over environments. Like we're writing like lots of like separate components that are running, like we want to run an isolation, like in security, this is very important. And also we want to make sure that we can like really like tightly scope our environment to like make sure we have like very few like variables, right? Like I don't know, like independent variables like going on. We also want to like ideally like publish some of the stuff we're working on as open source. Like we haven't done that yet, but That's one of our goals, and we want to make sure like we're starting out with a setup that will let us like easily like pull out the stuff that we're building to like publish. So Metaflow's support for like custom container images, like per step, we really like, and obviously like lots of other tools do this as well, but like we felt like Metaflow like did it well. Yeah, and resuming like workflow runs also very useful. Dynamic job fanout is super important for us. Like we have like a variable number of like vulnerabilities and like releases and stuff, and so we don't necessarily know like the structure of our DAG before we start like a workflow run, because that's important. And then we also want to be able to cache our work, because some of our computations are really expensive, and we don't want to run them like very often because they might not change that often. Like code bases often don't change. Like if a package gets a release every year, so that's one thing that we're so these are all the things we were sort of looking for. And also we want this to be easy to use. Like we're like pretty small team, like considering what we're trying to do, and we don't want to like, I don't know, like we're looking for like a very like tight dev loop, like iterate quickly, like ship quickly. Don't want to have to be like fighting against like the framework more than we have to. So yeah, so Metaflow, like we really like the support for custom container images, and the configs as well are cool. Like we want to use like a separate image for each step, and so configs allow, like we're using configs right now to do that, where we can just like pass in like a config file to our setup, and that has like a list of like maybe image tags or SHAs or whatever. And so for example, we have like separate configs for like our development versus like our production setup, and like we might pass that in through like a Helm config map or something. So yeah, we like that. Resuming, obviously, like I think we all know that exists, but it's a good box for us. And then we really like the like dynamic like job fan out. Like we think it's done very well in Metaflow. And then also like the products we create, like we just enjoy using it. The one thing that Metaflow is not really checked for us is the whole caching pure functions thing, but we'll talk about this because we think we have our own sort of solution that's not quite there, but like getting there. Yeah, and then so what exactly else we looked at to solve our problem? We looked at Flight. Honestly, none of us are like super experts in like workflow engines. We're all like sort of like quasi-security engineers who are sort of interested in building this tool, and we're just trying to like get things done. So honestly, like don't like take these assessments with a grain of salt, because like I would say that like these are all like great products, and yeah, and like I don't want to like make any statement that turns out not to be true. But yeah, for Flight, like we were looking at it, we liked it a lot, but we were not totally sure like about like the pricing and stuff like that, or if it had pricing. And yeah, I think overall like didn't quite like we liked like how Metaflow stacked there a lot more. Kubeflow pipelines, we actually started with that. We really liked it, but we had a really hard time with dynamic job fanout, and that was something that we eventually led to at the end of it. And then we had a whole bunch of other things to be considered. And again, like we're not like necessarily data engineers, and so like things like Airflow, like we thought weren't the right solution, but we probably could have made working if I'm sure there's some really elegant way to do this. But yeah, for like right now, like Metaflow seems really great, and so we've been using it for a while, and it seems like pretty cool. Yeah. So, any questions about like our sort of like breakdown about like why we think Metaflow is a good solution for us, or maybe any corrections about like maybe like we missed something critical about like these products that I mentioned? Cool. Okay. Yeah, so let's talk about what we're doing with it. So yeah, so when we're like figuring out like when we're trying to figure out a list of vulnerable code paths, we want to like download like a bunch of artifacts. We want like packages, we want like source code, we want like a list of vulnerabilities or CVEs, as like the industry term like is for that. We basically want to like for like every package, we want to like do like a bunch of like analysis that takes like all these like source repos and CVEs and packages and mashes them all together to figure out, okay, what are the vulnerable code paths? So this is a very, very simplified version of like what our architecture is. So like let me see if I can use the disk. So yeah, we start out with like our like vuln databases, and then we like figure out like what are vulnerable packages. Then we go to the package repos, we enumerate over them, and we figure out, okay, we have all these packages. And then we want to pull these packages, and we do analysis over them. And then we like collate all the results into like a big like list of vulnerable code paths that we send to our agents that are living in our customer computers. And so very, very simple high-level view, but that's sort of what we're doing. And so this is sort of like some scenes from like what exactly like our use of Metaflow looks like. So this is like a screenshot of our Metaflow DAG. You can sort of see like go back to my whiteboard. So yeah, like we're getting like releases and vulns, and then we're figuring out like what exactly is vulnerable. And then we're figuring like what sorts of analysis do we need to run to compute this. And I won't really go into that here, but like it's pretty complicated. And then we're once we figure that all out, we start downloading artifacts, and then we do a bunch of analysis. And I've just sort of obfuscated this a little bit just to like remove like unnecessary complexity. But we have like a bunch of different jobs that we do, and we all like and then like this is like where Metaflow is like shining for us. Like we have all these like tons and tons of just like looking through like source code bases to figure out like what was the commit that like a vulnerability was patched at and stuff like that. And yeah, it's pretty cool. And then we basically want to join it all together and then have our results that we like publish to an external data store. Yeah, and then just more like scenes from our Metaflow setup in case anyone's curious. Like, yeah, again, like lots of stuff going on. This is sort of an example from like one of our setups. Like, I mean, we have like a bunch of different parameters that we put in. So like this is not necessarily a representative flow, but I would say like this is like a good example of what we're doing. So you can see like downloading takes a while. Like, so we have these artifacts and the analysis still takes a while. And then we want to have like different phases of analysis and stuff like that. Yeah, and then like this is just a little like what we see when like in Argo workflows when Argo workflows is not trying to be like convenient and like collapse us all down. And so like now that might give a quick insight into our scale, but yeah, I would say like I don't even think like we're like doing as much fan out as we could be doing. Like this is we're like sort of like this is just like a subset like for like a pretty like small set of parameters. But yeah, and I've heard of like Metaflow teams using like having like really large fan out, like much bigger than this like little screenshot here. So this just like sort of meant to illustrate like the broad structure of our DAG. And this is like maybe a more like readable version. Again, like not much introspection to be done here, just like scenes from like our experience. Yeah, so I guess like a bit of like color into what we're doing. Like, does anyone like have any like reactions to that or thoughts or questions?
Hey, how often is that flow run? Like, is there some cadence? And I didn't really get how you detect when that specific line of code was executed.
Yeah, wait, what was the second question?
I thought you had the ability to detect when that the vulnerability was invoked.
Yeah, so
here's like the flow is triggered on some cadence, I don't know, and then that's separate to when the code is executing.
Yeah, Jeremy, you want to take that?
Yeah, so there's really two phases to what it is we're doing. What you're seeing right now in the part that Metaflow powers is the static analysis piece. Static analysis is just a fancy way of saying like we take dead code, it's not executing, and we're going to analyze how it behaves, right? The second part is our dynamic analysis, and that's what happens in our agent. That's what happens live. The basic idea here is that we want to be able to generate enough information on our backend to be able to feed our, agent data so it can efficiently determine whether you're executing those particular code paths or not. So it doesn't have to go and instrument every code path on your machine in order to do the thing, right? We're focused on the backend piece here because this is where we use Metaflow. That like forward detection piece, that dynamic analysis piece is our traditional agent. We're happy to talk about that. But yeah, we kind of wanted to focus on Metaflow for here.
Got it. Makes sense. Eric?
This is cool. So are you guys self-hosting?
Yeah, we are.
So I've never successfully done that. We've always just gone with the managed version. Like what was it like? Like was it easy to get started? Like have there been any gotchas? Like what's maintenance been like?
Yeah, I would say there's like I mean, not a super steep learning curve, but I think like definitely like need to like have like a lot of like SRE like hat knowledge. I think it helped a lot because like we have a lot of so we have a team that like hosts like Argo workflows for us, and like we have a team that like makes sure we have like compute instances available and stuff, and like Kubernetes clusters. So honestly, like we walked through like a lot of that like complexity like was just like completely abstracted away from us, and we were just like consumers of the platform. That said, like there was some stuff we had to figure out. Like I mean, like we wanted to like have a dev setup that was pretty beefy, and so like we ended up like solving some of those problems. And honestly, like I enjoyed it a lot. Like I enjoy thinking about those problems. I think it's like pretty well documented. Yeah, I don't know.
And yeah, if you've got someone running Argo workflows for you, that sounds like that would help.
Yeah, no, for sure. Yeah, that's things like Kita and like what's the word? Spiegel, like those are like technologies that also help a lot, and those were just like sort of out of the box for us.
Sick, thanks.
Yeah. Yeah, and I'll talk about this more as well. Yeah. Sorry, Nissan.
On the dynamic analysis, do you have to recompile all the binaries with like debug versions, or like how does that kind of work?
Yeah, Jeremy.
Yeah. So one of the nice things about working with open source software these days is that most of the open source package repositories actually already have debug symbols available for you. So we do use those as part of our analysis. In terms of recompiling, we recompile on occasion. Without getting too deep into it, there are situations where, for instance, upstream may change their compiler, they may change their build environment, that sort of thing, and it produces like significant deviations and offsets, it produces significant deviations and code layout, this sort of thing. So if you switch like F-stack protector levels, that's a particular problem. At that point, when we go to try and figure out like what are the vulnerable code paths when we're doing the binary analysis piece of this, we'll go through and we'll say, all right, we need to recompile this under the same compiler, generate our binary diffs, and then we can figure out from there how that associates back to the source code.
Got it. That makes sense. And regarding the dynamic for each task is a package, and I think you mentioned something like the fanouts are pretty small, so you haven't encountered any limitations with the fanouts yet. Is that right?
Haven't like right now, like what we've been running so far is like I mean, I'm not sure if you can really see like because this image is super granulated, but like usually like running over like maybe like I don't know like 100 packages for like sort of like what we're working with right now, and that's like a pretty big number because we're doing a lot of analysis for each package, and each package may have like a lot of vulnerabilities and different versions of stuff. But broadly, like we want to like be able to like work on like thousands of packages, each with like its own like sort of like actually like fairly static fan out. We have like a sort of like process for each package, like in that we have like certain paths. Like okay, we're gonna analyze the source code, we're gonna analyze like I don't know like the artifacts, etc. And so yeah, like right now we haven't had any fan out limitations. What we have hit are just like trying to like tune like Argo workflows and the various dependencies. Like we actually like I'll actually talk about it more later, but we like I would say we have a pretty beefy dev setup that I'm very proud of, and things like that. Like for example, like number of pods on the machine like was like overloading like the Kubernetes like API server, things like that. And so obviously solutions there, and I'll talk about like what we did. But yeah, like right now I haven't hit any limitations, but that may change as we really go for like what we're like the full meat of like the entire open source package ecosystem.
Awesome.
Cool. Yeah. So okay. So yeah. Some of these questions are actually related to what I'm about to talk about. So you may find some more interesting things to think about here and ask me about. So yeah, what we really liked about the developer experience, like the UI is amazing. Like it's honestly like Yeah, we think it's super useful. Like coupled with the Argo Workflows UI, like we haven't had any problems. And actually also like various other Kubernetes like observability UIs, but those are sort of like not really like included with Metaflow. Metaflow Dev was super useful. Like I'm not sure if any of the developers are here, but like kudos. I'd say we've made some modifications, but we're still using it. It's super useful. We really like writing flows. It's like very like IAC to us. I mean, that's not quite like the term, but like I don't know, it seems very like declarative, and that's always like rule of least power, you know. Yeah, and also like the actual like framework itself, like we find ourselves like reading the source a lot of the time, and we find that's very easy to do. And also just like we love the extensions. So yeah, and then things we struggle with. So we actually didn't realize that Argo Workflows was like a critical part of this for a while, especially for like when we were first going through development. And so so Metaflow at least from my perspective seems to like somewhat helpfully have its own sort of like scheduler and like controller to like manage jobs. But I think it's not quite as good as like Argo Workflows. Obviously, Argo Workflows is like super battle tested and like really well known for like doing stuff at scale. We saw some of this stuff and we were like a little frustrated at first, but then we realized that we weren't using it the right way. So yeah, I'm not sure like if there's any feedback from there, but just like I don't know, like if the community like has any like I don't know thoughts about that, then I'd love to hear them. And then we are still trying to figure out like how like when to run stuff in prod versus dev. Like it seems like Metaflow's answer to like running like sort of like iterating on workflows is often to like iterate in prod. I mean not like prod like we'll break everything if something fails, but just like run experiments and stuff and like try and like make like using like parameters like make things like very like configurable, and that way you don't have to like run locally too often. But I think I don't know, like maybe this is like a cultural shift for us where like we're very used to like having just like very like fine-grained dev setups, and so we've put a lot of effort in like making sure these dev setups are like can basically do what we're doing in prod with like very beefy machines. I wouldn't necessarily take that as like critical feedback. I'm just saying like that's like a point of friction we've had, and like I don't know, it's that might just be part of the journey of like developing the software in general. So yeah, and then yeah, not having like caching has been something we've also run up against, but I think we've solved this in a somewhat creative way. Yeah, and then like just a very like sort of fine-grained like point here, so I was mentioning earlier that we have separate container images for each like step. And the idea is we want to have like everything like very very tightly scoped and like not like each symbol like lives in only one image. And so one sort of thing we found is that like if we want to like unpick our artifacts, then we need to like have like types like available from like lots of different like packages that like, and we sort of organize our code into like different packages. And so far we haven't figured out a good way to like make sure like these types are like separate only to the container image, and instead of like having to import every type across every container image. That's like not really like a Metaflow like problem to solve, more so that like Metaflow is using Pickle, and Pickle seems to like just not be super like smart with this. We've like seen some like tools as we were like sort of like poking around to see like what might be a good example here. Like Dill is a tool that we like came across that seems like maybe like have some like do this in a slightly more like schema scoped way, but I don't know, like we're not experts here, and this is just like some problem we ran into. It's not a huge problem, like we can easily like find ways around this, but just like things that we've ran up against. Yeah, and so yeah, any questions about that? Like I know like feedback and like things like we've like had here might be like people have thoughts immediately.
What can you give an example of an artifact? Like is it like if you have a data class in step 1, you can't use that, you can't load that into step 2 because you defined it back in like some other code base?
Yeah, basically. I mean, so like say like we have like an intermediate like representation for like in one step, and then we want to and we want to see like make sure like all the, and we have our own like schema for that. Like we have like just defined like our like a Python like type, and so we want to like store that and like use it in the next step, and that's fine. And it makes sense. We have to have the schema in both of those steps. But then what we found is that if we want to like like it seems like Metaflow will need the schema for the schemata for like all the previous like artifacts that are come before like previous steps.
Oh.
Yeah, Jeremy has more insight on this as well.
Yeah, so I think we have a sort of couple. We have a couple of distinct problems here. The first is just in terms of the way that we would like to organize our code, because we do want to open source large portions of it, but not all of it. There's a challenge in terms of like how we organize, what types we expose, and what code we expose. And when you kind of have to expose like a really large section of all the types that are available to your programs in order to just get it to work, in order to get it to unpickle successfully, even if you don't necessarily use all of those types, just to deserialize them. Yeah, that causes some headaches there. There's also a challenge here in terms of, it would be really nice to be able to have like strong validation on either side of this. And when I say strong validation, Pickle is, Pickle tells you what types it's trying to deserialize. Your pickles themselves are the thing that carries that information. Nick mentioned a little bit about like memoization and pure function caching and that sort of thing. That causes some challenges there, just because as your types change over time, it means that you can't necessarily reuse a stored artifact in the way that you would be able to if it was, something like protobuf or that sort of thing, right? Just from a and I'm putting on my crusty security engineer hat now. Just from a crusty security engineer hat, it also means that runs are very porous. The security boundaries between these things are very porous because Pickle is equivalent to executing arbitrary code, right? Because a lot of what we do is analysis of untrusted binaries, not necessarily malicious, but untrusted. That's a thing that I think we might stare at especially hard. It's also, I think, something that's been sort of a larger problem and in Python and inside of especially inside of the ML metaverse, right? That's been a challenge, a source of security vulnerability. So we kind of have one eye out for that as well.
Seven?
Yeah, just wanted to mention that, of course, we recognize this as an issue. And there's actually active work in flight to support different serialization, deserialization formats. So hopefully this wouldn't be sort of like a problem for long.
That's awesome. If you could say any more about that, I would appreciate it. We'd be eager to sort of get ahead of the curve on that.
Yeah. I mean, basically, you'll be able to specify however you would want to serialize or deserialize these artifacts. So if there's a different mechanism that you would want to use, then you'd be able to sort of couple that.
That is super exciting. I am really looking forward to learning more about that.
Yep. I'm happy to sort of share some early work as well in terms of a PR. I can follow up on Slack with you on that.
Yeah.
Awesome. Thank you.
Yeah, another thing we're working on that's somewhat related is this concept of Metaflow functions, where we have relocatable functions in the sense that you can export a function, including its artifacts as dependencies, so that those dependencies don't actually conflict with the outer environment. Something you mentioned earlier about having to export all the types to deserialize a particular thing. If you exported it as a Metaflow function, then that's entirely self-contained. So whatever the minimum requirements are to deserialize that artifact would be in the function.
Wait, I haven't heard this term before. Is a Metaflow function something that's up and coming, or?
It's up and coming, yes. We gave a talk about it a couple of months ago at Kabuki. I can share the link to the talk.
Yeah, we'd love to see that. It sounds like it would honestly solve a lot of our problems. So, yeah. Cool. Yeah, I guess. Well, I mean, this sounds really good. Now we're going to talk about our sort of half-baked solution to all these things. Yeah. So I guess in terms of development, we have upgraded the tilt file to make it more like a bionic super thing. We're using S3 instead of Minio, and we're using our AWS credentials from our development setup. And then we've like sort of like passed in some Helm values for our workflows to do things like archiving pod logs, and then like garbage collecting all pods is also really important for us because we quickly like accumulate like hundreds of pods. And I know like the Kubernetes limit on pods, I think like 150,000 like pods at any given time, but we don't like even like getting there requires like a really beefy API server that's like, I don't know, we don't necessarily want to like super engineer, so like it's easier just to like get rid of all the pods and make sure we save the logs there. So that's something we've done, and that like has helped a lot in just terms of like our development workflow and our production workflow and just keeping things clean. Yeah, and then let's see, yeah, we've using S3, we're basically just using like observability for our dev setup, like Minikube, and then for our prod setup, we have like observability stack that again like other teams at our company provide for us, but we find pretty useful for like using things like Kubernetes and just keeping an eye on like our load and stuff like that. So yeah, just some sort of anecdotes. Like I don't know if any of these are like super like transferable unless you have a very similar stack to us, but some like how we've dealt with some of these scale problems. Yeah, and we've also like slightly like modified the Metaflow dev stuff to like do things like build images and like set up the configs that we pass to like have like to specify separate image SHAs for each step. Yeah, and then like probably the most interesting thing to this community is the custom decorator. Yeah, Seb.
Yeah, no, I mean, we'd love to take some of the work that you have done around Metaflow dev stack, and if you're open to it, upsource it.
Yeah, I mean, we'd love to like upstream all of this. Like,
okay,
yeah, I think like some of this stuff may be a little specific to us, but I think like we could maybe like put it together in a way that would be like broadly useful for the community. So like very happy to do all that.
Yeah, exactly. I mean, the observability stack is something that we wanted to add, but we haven't gotten around to it.
Yeah. Well, we might have some interesting things for you. So yeah. Cool. Yeah. Yeah, and then so I think custom decorators is probably like one of the more interesting things we've done with Metaflow, besides just being a consumer. And specifically, these are around the problems like memoization and validation. Like, I mean, Jeremy and I were talking about this earlier. Like, sort of things we sort of wanted that we felt like Metaflow didn't quite have, and so we built it. So the first thing is like memoization. So some of this stuff is really expensive. Like compiling like source code is like famously like one of the most like CPU and memory intensive things you can do on your computer. And so we want to ideally like, and also like this is like right for like caching, because we have like source code does not change like that much, especially when you're like pulling the source code associated with a specific release, then that like will hopefully never change. And so like a lot of this stuff we can like compute once, and then like we may never need to compute it again. So we really want to like minimize that, because that'll speed up our workflows a lot, save us a lot of money in terms of like just compute cycles and stuff like that. So we found like this custom decorator framework laying around. We've seen people talk about like the devs, like Metaflow devs, like you talking about on Slack. I'm not sure like if it's like in like a state that you would consider stable or published, but we seem to have got it working. And so yeah, Seven.
Yeah, no, I mean, definitely this framework is something that we use quite extensively. And there's actually one more mechanism of writing custom decorators that's about to be published. If you want to take an early peek and test it out, happy to sort of like share that.
Yeah, totally. Yeah, I mean, yeah, we'd love to do that. That would be great. Yeah.
Yeah, I'll drop the link in Google Chat.
Cool. Yeah. I probably won't be able to see it because I'm on presenting, but I will take a look after.
Sure.
Yeah. Should I move on? Like, I really want to take a look at it. I'm very curious, but I'll save that for later. Yeah. Anyways, so like just dealing with like the broader problem of memoization. We know like Argo Workflows has like technically memoization. Unfortunately, Argo Workflows doesn't really work for us because the etcd max value size is like 1.5 megabytes, or like for Kubernetes, like so Argo Workflows memoization uses Kubernetes config maps, which have a max value size of 1 megabyte. So basically, like for some of our artifacts, like we're like passing out like massive code bases and massive artifacts, and it's just like a lot bigger than 1 megabyte. So I would have loved to use like this sort of built-in tool, but didn't really work for us. So I guess like if anyone's curious about how we did it, so we have like this decorator framework, and we're just using some of the hooks. So before like the step executes, we check whether or not so we hash the inputs, we check whether or not they're present in S3. It's like a memoization key. And then this hash also takes like the image name and like the step, like source code. And then if we do have like sort of that input key with that memoization key, then we just copy all the values and we set them to like the next attribute. And it's kind of a hacky way, but like seems to have worked for us so far. If it's not present, then just like compute the job as usual, and then like on the task finish hook, then like create that memoization key and copy the values at like the output S3. So yeah, basically just like if it's there, then use it. If it's not there, then put it there. With like various like primitives here. So the one like caveat I would say is that like this isn't totally working yet. Otherwise, we would be like all over trying to like, hey, like we've built this cool thing and like we want to like give it to everyone else. So in for each, like it's a little bit more complicated, and we haven't quite made it work there. Like the next attribute in for each is not quite the case. Like I know that there's this like for each stack like property for the flow like class, and that seems to be like different. And honestly, like haven't quite like dug deep in like why that didn't work, because we were working on something else. But yeah, just saying like that's like sort of the state of development. These are the problems we're still trying to solve. And honestly, like Metaflow devs, like y'all might have like some very useful insight for us here. And then yeah, and then other things like right now we're just using S3 to use like I know Metaflow has a really convenient S3 API or SDK, I suppose. But like I don't know, other object stores like S3 is convenient for us, so we've done that. But like we don't like our sort of like tool doesn't support other stuff. And then also like if, for example, like someone is using like the batch like decorator, so the Kubernetes decorator, then like we don't take that in. So that's something else we need to build. Again, like we don't use batch with Kubernetes, so like we haven't necessarily done this, and we're sort of just trying to make this work for us like before we really try and like propagate it out for everyone. But yeah, these are sort of things we want to solve next before we consider this like something we want to upstream. Yeah, I guess like any thoughts about that? Like I know like y'all probably like are very, very familiar with like the structure of like flows and how the awful things we're doing to like copy outputs and stuff.
Yeah, go ahead, Seven.
No, just one quick comment was that, I mean, if you have things working, but let's say it only works for S3 and Kubernetes, I mean, that's still sort of like, is a contribution we would be very interested in taking a look at, because it can always be sort of like extended later.
Yeah, I think like honestly, like I'm very happy to like upstream with just S3 and Kubernetes. The one thing I'm really worried about is the for each, because I think for each are like a pretty like critical like part of Metaflow, and memoization just does not work correctly for each. So that's
I
like
was gonna add that we do have a construct coming for conditional steps, so you could potentially use that if the data is there. Just skip that step.
conditional step, as in like before the step runs, like we check like it has to pass some condition, and that condition would check. Okay, yeah, that'd be cool. Yeah, I'd love to see that. Cool. Yeah. Yeah, again, like I would say like I would split this as like 60% complete, and like complete being like MVP rather than like amazing feature that like will like be a native like thing in the code base. But yeah, but I think like we're pretty happy with it so far, and obviously we'd love to like talk about like upstreaming. Like all this is like all of what we're doing is like we want to give it back, and we're just trying to like work on it and make sure it's good. So yeah. Yeah, anyways, so yeah, like what we're doing, we want to like talk about streaming. So okay, so the next thing like we built was like validation, and Jeremy mentioned that like we're like taking like untrusted inputs from the internet, and those are potentially like kind of crazy, like, and that could like I don't know result in like arbitrary code execution, and just I mean like also like correctness, like what if there's like something that like doesn't quite match like the schema that we're expecting it to match, and so like I don't know, we want to be able to like reason about our system and like add like guards. And so yeah, basically just like what we did was we also wrote an extension like that has a decorator, and the idea is that we in our like and like before and after the step we want to pass like these like value and type annotations, and Metaflow provides them for us, which is super nice. And then we want to use Pydantic, and we just check that the values match your type. So like nothing crazy, just like something that we want to like see that is like checking the boxes. But yeah, super useful for us. Yeah, Jeremy.
Yeah, I just wanted to add one of the, I guess, two of the other reasons why it is that this is really valuable for us. One is that we often have like different people working on different stages of our pipeline. And so, when expectations are changing at an earlier stage of the pipeline, when, types are changing, that sort of thing, it's convenient to be able to have sort of type assertions later on where actually this is structured this way. Like it's not, if something breaks, like it's not because my inputs are the same and my code is broken. It's because my inputs have changed in some way that I wasn't prepared for. So there's that. And also it just feeds into our testing system overall. Makes it easier for us to have at least very basic sanity tests automatically.
And I guess the other thing I'll point out is that I think the author of this like extension, Jen Chow, is in the call with us right now. So hat tip. Yeah. Cool. Yeah. Any questions about like validation or what we're trying to do with it? All right. Yeah. So I guess working at scale, like again, like we've talked about like most of what we've done with it, like Argo workflows, like useful that we have a team that manages this for us. But like we found that it really fits our use case well, and like we like using it a lot. Yeah, like again, like pod garbage collection, like that has been like something that we needed to like just figure out and just make sure that we had set up. And then yeah, so we have like again like our SRE setup, like our SR team has like a log storage like solution for us, like the Stack, and also we have a really well structured Helm like Argo like chart of charts, and that's also super useful. So I think like those things like help us at scale a lot. Yeah, Savin?
Yeah, just wanted to mention if you haven't already noticed this, but all task logs, they automatically are pushed to S3
Through Metaflow?
through Metaflow and are accessible at any point in the future. So just in terms of like archival.
Yeah, that's a good point. Yeah, I have noticed that. I think like, so we use Argo workflows as well as the Metaflow UI a fair amount. Like the Argo workflows has like a nice like graph that we use. And yeah, obviously like, yeah, but the pod logs, if we really need to get them, like Metaflow has them. So that's a good point. Yeah. Cool. So yeah, and then just in terms of like the nitty gritty, like we have a lot of data going to S3 that we're sort of just may never touch again. So like lifecycle, just to make sure we get rid of it efficiently is good. And then another thing is that we have been like, at least I have been, maybe not Jeremy and others have not been very impressed, but Minikube has honestly been a champ with the things we're asking to do, and it is definitely like gone above and beyond the Call of Duty. So I would say like, yeah, like again, like you have to have like a beefy machine and you need to like understand like Kubernetes pretty well. But I would say overall, like just things like, yeah, like having no limit on CPU memory can do powerful things. So yeah. So yeah, I guess that's everything we have. Like I know we've been like having a like just a dialogue throughout the whole talk, but like any sort of like top level questions that people have. Yeah, wow. I guess we did answer a lot of questions before, so not really expecting like.
So I'm quite curious if you're open to sharing this. Like, what is the scale of compute here? Scale of tasks, flows that you're running on a day-to-day basis?
It is going up right now. I would say like each workflow run involves like 1,000 jobs, and we're rapidly increasing that. So not like crazy amounts, but enough to like require some consideration for scale.
Okay.
Yeah, Jeremy?
We are also something that we're messing around with a lot right now is actually having triggers between workflows so that so that we can kind of separate those out. Part of that is because I think there was a question earlier about kind of the cadence at which these fire, and a lot of these, something that we've referred to a lot of times is that we have pieces of processing that want to happen at when a piece of source code change, and we have pieces of processing that want to happen every time that we pull down more packages and that sort of thing. triggering workflows between those kind of matches that pattern relatively well. So that's something that we're playing around with specifically to keep our individual runs small. And Nick has talked a lot about our trying to make a local dev setup work and that sort of thing. Having those small dev runs really useful for that. I get to take the blame on that since my background is as embedded security person, and I'm used to working working locally. But a lot of our goal there has been try and keep runs small and as small as possible. Just to make them work locally.
Yeah. Any other questions? All right. Well, I mean, Seth?
Yeah, I would love to follow up on Slack to figure out sort of like next steps on just like improving the entire Metaflow dev experience as well as some of the memorization work that you're doing.
Yeah, totally. Yeah, I think I would say like we have like done all this stuff with like an eye on like upstreaming all of it. So I would say like we're very excited to do that.
Awesome.
Cool. Yeah, well, I guess, thanks for having me, and thanks for having Jeremy and the rest of us. Like, we love Metaflow, and we love working with it. So, and we also, we really appreciate, I think, like, one thing that we like a lot about Metaflow is that it seems like it's moving in the right direction, and, like, seems like something we can count on in the future. So, yeah, things like this, like, make that sort of, like, confidence build. So, yeah.
Awesome. Thanks a lot, Nick. We'll let you know when the video is available. All right. Thanks everyone for attending. Bye all. Stay in touch for the next office hours.